Hi and welcome back to this series of sessions on OOPS concepts. I'm sure before viewing this session, you must have already seen the introduction part or the session on the introduction of OOPS concepts. Then of course on the relationships in the OOPS concepts, the UML relationships, how do we represent them in the UML diagrams, and all these things will be a prerequisite for understanding this session. My recommendation is that you first visit those two videos and then you can listen to this video. Today we are going to discuss more about the concepts involved in OOPS. Let us go one by one. Before going ahead, just let us recap about how do we represent a class, how do we represent an object in UML. It's the same slide which we have seen in the probably in the introduction part, but this is the way as a three partition UML notation we represent a class. In class we have got the attributes as a key value pairs, with key being the name of an attribute and value being the data type of that attribute. Of course there is going to be a separate partition for operations associated with that class. Whereas object also is represented like a partitions in UML, only difference is object name is given colon the type of object to which it belongs to. It is also used with the underline just to indicate quickly that this is object representation and this is not a class representation. Objects also have key value pairs as an attributes, with the difference that key is the name of attribute and value is actual value of that attribute. Now even this set of specific values of all the attributes at a given moment for any object is also called as a state of that object. For example, this floor 1 printer as an object is at a state where type is laser, ID is this and location is this, whereas another object of same class called as a printer object is at a different state. State means a combination of attribute values. This gives us a new understanding about the state of an object. So every object has got a name, every object has got attributes, every object has got operations, every object is at a given specific state based on the values of the attributes for that specific object. We know that for different objects these three things are not going to change because type will always be string. So attribute name and data type will not change, but attribute name and its specific values will change. So this is the way we are going to represent objects and classes. This was just like a recap, and let's go ahead and start with our understanding of specific concepts. Now let us go a little more deep into understanding of the data or the state of an object. For example, this is a class called as a DB connection. Now DB connection has got few attributes, namely username, DB password, database and port, and of course there is some method called as a connect. This looks like a good representation of a class in UML and in an object oriented way. Let us consider different object creations of this class for different users. There are three different users, namely say Amar, Akbar and Anthony. Now for Amar an object is instantiated because of course the Amar as a client to the application would like to use the database services. Now for this object a state is username is equal to Amar, DB password may be some alpha, database is with the database name and port for example 3306. For another user called as Akbar, same again the state of that object is username is Akbar, DB password is some beta, database name, port. Similarly for Anthony, I will not read it out. You will notice one thing, there are certain attributes whose values are changing for every object, and there are certain attributes whose values are not changing because all Amar, Akbar, Anthony are going to use the same application, and probably application is using a same database for every user. because no application will be stupid enough to instantiate a new database instance for every user. And here we find a difference, that there is certain data which is object specific, whereas certain data which is constant for all the objects of that class. For example, username and DB password are different for every user, whereas the database name and port are constant irrespective of which object is using it. If we can separate them out, we find that data represented inside this blue rectangle is very specific to that object, and data represented in red is very specific to a class of that object. So we find out that these two attribute names are more specific to every object and they are going to vary with the values, whereas database and port, it will be enough if at all we could represent them only once for all the objects together at a class level. This is where data of an individual object and data which is common to all objects need to be processed separately. This is where we are going to make a little bit change in the representation of the attributes. Once we understand that, this will be easier for us to understand that data need not be replicated unnecessarily if data is going to be just a copy-paste replicas. For example, the database name and the port number was nothing but a replication or copy-paste in all these objects. To avoid such, say, the replication of data just by copy-paste, object-oriented programming gives us a separate understanding from the word static, and we represent that kind of data with a different symbol itself. What we do is we represent it by underline and we do not represent it at an object level. What does this mean? This means these two attributes or these two values for a data are going to be specific for every object, whereas database and port are not going to vary for every object separately, but they are going to remain constant if we can declare those at the class level. So underline database :string means there is a data value which is required for database if you want to create a DB connection, but this database and port, they need not be replicated for every object, but those can be assigned a value once for given class. And here a word static gets introduced. So data which is relevant for every or individual object is called as an instance data. So username and DB password, though they are described here, they make sense for every specific object. Whereas data which is going to be a common for all the objects of that class and which can be represented only at a class level, which is a data associated or attached at a class level. And that's why the static data or static attributes are going to be attached at a class level and they are not attached to any object. There is going to be only one copy per class, and all the objects, they can use the same copy. So when user 1 on this named connection is going to actually connect to a database, it can always use this database and port. Same is true about the other two objects. Now this is about our attributes. Now for operation, it is going to be a little bit different. Even operation connect can be a static operation if it can be called on the DB connection class itself. We know that in case we want to call any operation on a class, we need at least one object. We can always say in our language pseudocode, for example, vehicle v equal to new vehicle and v dot start. So basically we need an object of a class to call operation on that object. But sometimes it is not required to actually create object of that class and call the operation on it, whereas the operation itself can be described as static. Of course, in this class, this operation being called as a static method can access only static data. So remember this catch, even though we are not going to go into depth of this, but when someone calls a connect as a method, connect method will be called on the class name. Remember, I'll repeat it, static operations are always called on a class name and we do not need to instantiate object of that class. Now this means we can call simply in our code db connection as a class name dot connect. Obviously, you will conclude we have not instantiated any object of that class yet. And if there is no object, this data does not exist. This data does not exist, and that is why whenever we call a static method, we cannot make use of any instance data because there is no instance. For example, if you are a Java programmer, say this or a self or whatever it might be, the self reference of that object is not existing, and that is why remember a rule. Even though we are not going to go into depth of this rule at this moment, any static operation can access only static data. This operation cannot access values of these two attributes because they are differing for every object. So in conclusion, connect is called as a static operation. Static operation can be called only on the class name. It does not require any object. For example, this connect, suppose someone says db connection dot connect, there is no username and there is no db password. For example, this operation internally might assume a default username and default password, and it will connect to a database. Static operation can access only static data and it cannot access instance specific data. Static operations are different than instance operations, even though they look wise, they do not look different except the underline in the UML notation. And static data is never shown in the objects because it is not attached to objects, but it is attached to class. There is only one copy for all the objects belonging to that class. In general, usage of static operations and static data is generally discouraged in object-oriented programming. Why it is discouraged? Because simply it is not making use of objects, and what we have learned earlier, object-oriented as a paradigm or object-oriented environment itself believes in creating objects and giving them autonomy so that they can talk to each other, they can pass on messages to each other and get the work done in a collaborative manner. That is where statics, they come as an obstacle in between, and that is why usage of static operations and static data is in general discouraged, but there are certain occasions where we require static data and static operations. A typical usage of such static operations and static data will be for the util kind of functionality, where it's just a utility, maybe a validation of a very specific string so that it is only alphanumerical. Now it is not a property of any specific object, but it is a common property or common functionality required across the application. For such functionalities, we use static, but we need to maintain them at a minimum level. The best example which you will come across as a static is the first method in Java, which is called as a main. If you remember, the way you remember the main method itself is public static void main. Observe the word static. How do we represent that into implementation language? Again, we are not going to consider it at this moment because our complete training, this OOPS concepts training series itself is language independent. And that is why we are not going to talk about the implementation of any of these concepts. It varies from language to language. There is another concept about a data itself. Let us consider a situation where we are trying to model a very common class which many times is required in the graphics application called as a point, which is a Cartesian coordinate. Cartesian coordinate is xy, it is represented by value as a xy, but we know that a point also can be represented in another pair of values that is called as r theta in polar coordinate system. So either we can represent it as the Cartesian coordinate frame or polar coordinate frame. This is what we have learned in our say junior college. Suppose we want to represent them, we have got two alternatives of representing a point class. Which one to prefer? We have seen from decomposition, if we find that the point is most suitable for representation of a Cartesian, we accept this representation. If it is suitable for r theta, we accept this representation. Now let us see actually the situations in which one representation of point is favored over the other. For example, if the point representation is in context with the graphics application where we are supposed to draw something on the screen. And obviously r theta is not a useful because it's a polar coordinate, and that is why preferred thing is x and y coordinate system or the Cartesian coordinate system. But imagine we are going to write some program for the astronomy where you know that planets rotate in general in the they move in the radial as well as the tangential directions, and that is where the r theta or the cylindrical coordinate system might be used. Of course, in three-dimensional third comes as a spherical one, but we will not go into that depth. So either cylindrical or rectangular, they are helpful in different type of context. For example, if we want to move a point on the screen, we just give a dx and dy displacements in both the directions and we can move it easily. Whereas suppose for the Kepler's laws, you know that Kepler's laws about the planet rotating around the another say star or a planet, and Kepler's third law says that the area swept in time by any say rotationally moving body against the another gravitational body, it sweeps equal area in equal time. Anyway, we will not go into depth of the Kepler's law, but if at all we want to calculate that function, polar coordinates are useful because maybe a radial dimension will remain constant and delta theta, as into the calculus part of the mathematics, we will be using r theta coordinates more suitably. For any say discrete mathematical methods, we give a delta increment to theta and we calculate all the rotation things. So you will find representing it only in one way will bias towards the usage of it. But whenever you see any application of the astronomy and at the same time you want to represent that also on the two-dimensional screen, it becomes essential that we want to have both the coordinates in place. And that is where such a hybrid model of representation comes into picture. Now you will find a given point can be represented by either r theta or x and y, but only one pair at a time. If we give 4 different values, they will start representing the two different points simultaneously, and which is the wrong one. So if at all we are going to use r theta coordinates for most of the application, because application belongs to astronomy, but while showing on the screen, we require that point to be represented as a pair of coordinates x and y, or as a projection of a given plane. You will find x and y values can be calculated by a given rule from other two attributes. Meaning in mathematics there is a concept called as a dependent variable and independent variable. And we have learned in our algebra that x is equal to a plus b and y is equal to x plus 2b or something like this. So here a and b are independent variables, whereas x and y are dependent variables. So you can assign any value to a and b. Once you assign values to a and b, values of x and y are fixed. You cannot change them. Exactly same thing happens here. Once you assign a value to r theta, values to x and y are calculated automatically by a simple formula: x is equal to r cos theta, y is equal to r sin theta. If you want to refresh your knowledge of mathematics as an extra interest, you can always refer to basic mathematics books, but that's not our focus. Our important point is values of x and y here cannot vary independently, but they can be always derived from values of rest of the attributes or some other attributes. So these are called in a similar way to a derived attributes, and these are the basic attributes. So derived attributes we need to make sure that we represent separately in UML. So you will find x and r theta are essential attributes, whereas x and y are good to have attributes, but even if those are absent, we can always calculate those from r theta. But if someone wants to reduce the calculation time, then maybe this pair can be always kept ready with a point at all given moments. Only thing is someone will use it, but we cannot give access to the outside world to change values of this x and y. So this is a set of derived attributes, And derived attribute in UML is represented by giving a slash in front of it. Now why do we represent it? See, UML is actually to help the designers and implementers based on our analysis model. If this can give an indication to a designer or the implementation development team that these two are attributes which are derived attributes, now what are all things they can do? Very important thing, if this point class or object of point class is going to be saved in a database, we do not need to save these two values. So for a table called as a point, we need to have only two columns, that is r and theta, and x and y are not required because every time you retrieve those values, x and y can be calculated. In case we are going to serialize this data, we do not have to serialize these two. We can serialize only these two. So this is where the derived attribute representation helps us in the design stage, implementation stage, and the application can really get efficient. So remember how we represented static by underlining, how we represented derived attributes by providing a forward slash in front of the attribute name. Of course, this is a UML representation. Actual usage of these attributes I explained to you. For example, making the attribute as a persistent, we need to think of derived attributes separately than the mandatory attributes. Now let us focus on the different aspect of object-oriented programming. That is, how to avoid a code duplication. In general, whether it is object-oriented or not, software always aims to reduce the code duplication. If at all we find the code is written at multiple places, always software tries to reuse it. Let us consider this example of a class is called as car, truck and scooter. Maybe in the application which is dealing with vehicles, we might be modeling these three classes like car, truck and scooter. If we observe carefully, the red rectangle shows the attributes which are common to all these three things. For example, RTO number and engine power is common to all three, and that is why these two attributes are appearing in all the three classes. Similarly, start and stop operation is a property or the feature of all the three classes, and that is why it is also appearing in all the three classes. We find this is where the code, rather the features, are replicated or copy pasted into different classes. Now to avoid this, first of all, let us understand that there can be certain attributes and certain operations which might be common to multiple classes in the given domain model. So in this diagram, if you observe carefully, the attributes and operations marked by a red rectangle are the common ones. Those are present in all three. Whereas the attributes and operations marked by blue underline are going to be a proprietary properties or features of those classes. For example, music system brand is only a proprietary property of a car and it is not present in truck or scooter. Similarly, play music operation, load and unload operations are very specific to car and truck classes respectively. That is why you find that there are two types of attributes and operations. There will be certain operations and certain attributes which will be common to multiple classes, whereas certain operations and attributes may be proprietary for a given specific class. Let us see how we can avoid such kind of a code duplication by using something called as an inheritance relationship. By now you must have already understood by the earlier sessions what inheritance relationship means. But how to use it for code reuse, let us try and evaluate it. Now whatever was shown in the red rectangle in earlier diagram or earlier slide, which was common to all the three classes, we have pushed it up into a common base class called as a vehicle. And as we have already discussed for car, truck and scooter, calling them together as a vehicle has nothing to do with a software field as such. In every day-to-day life also we call that as a vehicle. And everyone knows that having an RTO number is not a property of a car, truck or scooter individually, but it is a property of every vehicle. Similarly, engine power. Car, truck and scooter, all three do have the engine power. Start and stop operations, yes, all these three vehicles do have. But having a music system brand is a proprietary property of a car, and that is where we find every class has got certain properties or features which are proprietary to that class, which are described in that class itself, and there are certain features or properties which are inherited from a base class. For example, RTO number, engine power, start and stop are inherited features from base class, whereas in addition, car also has got its proprietary features. Truck also has got in a similar way, which we can understand exactly in the same way. Now, principle here is a very easy principle to remember. It says segregate that which is common and separate out that which is varying. We find that these two sets were common, and that is why we segregated those into the base class. And whatever was varying, actually a variant, we have shifted, or we have rather maintained at the derived class level. So you will find that any attribute or feature, if it is common, which is not going to vary in all three, we shift it up. Whatever is going to vary, we are going to keep it at a proprietary level itself. It's true not only about the direct attributes and direct operations, but also indirect attributes like the relationships. For example, every vehicle has got an asset value. For example, its purchase date, purchase price, and of course the operation called as a compute depreciation. Now it is applicable to scooter, truck and car as well. And that is where you will find all these three inherit this relationship from a base class called as a vehicle. Similarly, that any other relationships and the attributes and operations, whatever is common, we push it up, whatever is varying, we push it down. And that is where we apply a code reuse principle, because this much portion is reused in the child classes. In case we want to make any changes here, we would have been forced to do at all the three places, and if we forget at one place, there will be a problem in the software. But here you will find making a change at this common level itself is going to impact all three in exactly same way, and software will not function in a wrong way. That is where keeping application in sync becomes easier if we use this kind of a code reuse. So remember, this use of inheritance is for code reuse. There is one more use which we are going to see later. Let us see one more concept which is very important in OOPS. That is called as operation overloading. Operation overloading means same method is present multiple times in a given class, where the method name is exactly same, but method signature is different. Let's try to understand what do we mean by a signature. In a very loose sense, what we can consider is signature means collectively giving attention to operation name as well as the parameter types, not the parameter names. See, this n1 is a parameter name, right? It's a formal parameter name, but int is a type. For example, add n1 int into int. Here, add is an operation name, n1, n2 are the parameter names, the local names inside a method, and int is a data type for it. Similarly, if we consider the signature as including both these parts, then roughly we can assume signature of this first method is add int int. Of course, there is nothing like this as a definition, okay? So do not be under impression that somewhere you can address it. But in general, if we consider this as int, add int int, this is indirectly helping us understanding what is signature. Similarly, signature of the next method is something like add double double, means it's a add method and there are two parameters with double as a type. Similarly, there should be add complex. Now here it is a typo, but I don't think it needs extra explanation. Basically, it's a add complex means add method, and there are two parameters required which are of type complex. For example, if it is a calculator, then obviously calculator may need to add different kinds of data. Now this is where operation overloading comes handy with it, because the fraction is a data type which has got numerator and denominator, complex is a data type which has got a real and imaginary number, and inside add method there are two parameters of this type and there are two parameters of fraction type. So you observe calculator has got 4 methods with exactly same name but 4 different signatures, right? And this is where we find operation overloading. Do not get confused between operator overloading concept in C++ and operation overloading. Okay, we are talking about operation overloading and not operator overloading. Operator overloading we are not going to consider in UML because that is very specific to C++, and as I mentioned earlier many times, our course is going to be completely language independent. Hence we will not be talking about operator overloading, but we will be talking about operation overloading. This is also called as a static polymorphism. Of course this is really not a polymorphism in sense, but some people or some books may call it as a static polymorphism or compile time polymorphism. Why compile time? Because these methods are binding to their data types and their implementations at compile time. All these 4 methods will have their own implementations associated with it, and that is where the compile time binding comes into picture. Let us consider next variant of a calculator class. Suppose calculator class is present like this. Now obviously we find there is possibility of operation overloading because the operation name is exactly same. Let us give attention to its parameters and find out whether there has been the operation overloading or not. Now let us find out the signatures of the operations individually. First one is say add amount double. Now amount and interest, these two are basically the parameter names, and double is the type of parameter. Similarly, a return type is a double, but return type is never considered as part of the operation signature, so we ignore it. So we say it is add double. We have to of course maintain the sequence. This is double, this is double. Second operation is add time, which is of double type, and second parameter increment type is of a delta t type, something which we are not really worried about. This D should have been uppercase because it is a type by itself. But this double and delta type is a different kind of a signature, because if we consider the signature of this operation, the signature will be add double delta t type, and it is different from this. So obviously these two methods there is operation overloading. Between these two methods there is a operation overloading which is happening. Of course we need to ignore the return type. Let us consider the third one. The third method signature and the first method signature, they are very near to each other. Let's consider them. First method signature is add double like this. The third method signature is again add double, but return types are varying. First method is returning double type, the third method is returning int type. Question is this operation overloading or not? It's a bit tricky question. Remember, in a method signature we do not consider return type, and that is why both these methods are exactly having the same method signature. And listen carefully what I am telling about. In this case, between the first method and third method there is no method overloading which is happening. Such a code will not be accepted because there is an ambiguity. Because whenever we call this method, The identification is based on the signature, and if you find the first and third both methods signature is exactly same at double double, and there will be a confusion between these two or collision, and such method signatures will not be allowed in a class. So remember, if any question is asked whether it is operation overloading or not, so answer is this is not operation overloading, because we cannot have two operations with exactly same name and same signature in the same class. It's a collision. So what is operation overloading? Remember, same method but different signatures. Same method name or operation name but different signatures. Here method and operation we are going to use little bit like a synonyms. But in general, whatever is just the given as a declaration is generally called as an operation, and wherever there is an implementation we call it as a method, or in the implementation stage we call those operations as methods in many times, but right now we are going to use them as synonyms. Now there is another variant also. Let us consider this case. Now you will find calculator is a base class and some precision control calculator is a child class. So parent class, child class. Okay, you will find here there is a method called as add with signature add double double, and return type of course it is double, but we are not going to consider is a part of method signature. In a child class you find that there is another method with exactly a same name, but the signature is add double double double, because it is going to use 3 parameters, input parameters, and that is why we find method signature of this and method or operation signature of this, they are different. Now how to decide whether there is a method overloading or operation overloading or not? We combine things which we have learned together about inheritance. You know that whatever is in the base class operation, it is inherited by child class. Now this child class also has got a method which it inherits from base class, purposely shown it is in a gray because it is not written in this class but it is inherited from a base class. So within this class if you see, effectively there are 2 operations. And now let us apply our rule of operation overloading. The rule is these 2 methods, method name is same or operation name is same, but parameter signatures are different. So we conclude this is method overloading. So remember, method or operation overloading can be done in a same class like a previous case, or it can be done in a parent class and a child class like this. This is also an example of operation overloading. So remember this, it can be done in the same class or in a parent and a child class. Now let us go over to the next principle, which is called as operation overriding. It is different from operation overloading. This is the confusing portion where most of the candidates they make mistake. Operation overloading was method name was same but parameter listing or the method signature were different. But in case of operation overriding, let us consider the case where the parent class is going to have a method or operation signature, for example as a start, whereas a child class also. We have seen in a same class we cannot have 2 methods or operations with exactly same name and same signature. We cannot have it. I told you in the method, the operation overloading, that it is not possible. But let us try doing it in a parent and a child class. For example, this start method is there. In a car class, this start method is inherited. So you will find now in a car class, one method is written in the car class itself. It's a proprietary method of a car class, whereas the gray method is inherited from its parent class. And surprisingly, you will find there will be two methods visible in a car class which are of exactly same signature. What will happen to it? Will code allow this or not? Surprisingly, a rule is if such a case is there, this is inherited operation and this is local operation, the local operation is preferred. Once we come to that conclusion, inside a car class, this operation will be preferred and this operation will exist, and the operation which is inherited will not be used here. So this start method is for vehicle, even though car is inheriting the start method, but as the car class also have got the operation or method known with exactly same name and same signature, this start will be correct one. In a sense, what we have done here is we have overruled or rewritten this operation called as a start. Exactly same thing has happened in the scooter. This is belonging to a scooter method or written inside a scooter class, whereas the gray one is inherited. Gray one is ignored when the local version is present, and that is where the start method in the car class and start method in scooter class will be overriding the start method in a base class or vehicle class. This principle is most important in object-oriented programming because this allows us a great miracle by which object-oriented programming has really given us the best results. Now let us find out what exactly operation overriding means. Operation overriding means same method name and same signature in parent and child class remain three parts. Same method name which was common with method or operation overloading as well. Same signature is differing from method overloading because in method overloading or operation overloading signature was not same. But in operation overriding signature remains same in the parent and child class. And of course this is in the parent and child class. In same class we cannot override a method or overrule a method. Now signature we have seen it is operation name and parameter types, that just for a revision purpose. Whatever version of start which is inherited one will be ignored from here, and the start version which is written in a car class will be preferred. This principle can be remembered even though in the technical documentation this is called as overriding, but it means parallelly overruling, because this car class is overruling the signature which it is getting from the base class, or rewriting or overwriting. For example, car class writer is saying even though there is a start operation inherited from its base class, please do not use it, use the operation which I am writing in a car class. That means it is overwritten or rewritten. What about the implementation? How to do it at the implementation stage? The implementations are completely language dependent, and hence we are going to ignore it how to do it in two languages. Because in C++ there will be different mechanism, in Java there will be different mechanism. Only the commonality is method signatures are exactly same in base and derived class. That is what is we call it as operation overriding. Operation overriding helps us in achieving something called as a polymorphism. Let us see what do we mean by a polymorphism. Now same thing what we have seen earlier, there is a vehicle class, there is a start operation which is defined here like something, a print message that every vehicle starts in different ways. It's a print message which this is called as a dog-eared comment, and dog-eared comment is connected with a dotted line to the element which is this method about which it is giving more explanation. Now the child classes car, scooter and auto rickshaw are inheriting it, but at the same time they are redefining it or overriding the operation called as a start. Now car class writer has written the start operation, and inside it is written print car starts by key. Now let us take that as a pseudocode and let us not attach it to any specific language. For example, there is a sysout statement or print statement with car starts by key. Scooter writer has overridden it in a different way. Scooter starts by kick. Auto rickshaw has written in a different way. Auto rickshaw starts by pulling handle. And these are the three different ways by car, scooter and auto rickshaw start. You will find vehicle describes that there must be some start implementation, whereas car, scooter and auto rickshaw, they provide different implementations to operation called as a start. This is where you will find out the difference in the terms used as operation and implementation. This is typically an operation. That start is an operation which is inherited by all three but redefined by all three child classes. This start operation is implemented in different ways by three child classes. But remember again, the same operation and multiple implementations in child classes. This is what is called as the polymorphic behavior of inheritance hierarchy. What happens is, whenever we make an instance of a car or a scooter or auto rickshaw and call a start method on it, appropriate start methods will get called. But I am sure no one can appreciate it, because yes, what's great in that? If I make the instance of car, this will be called. By scooter, this will be called, and by auto rickshaw, this will be called. Nothing great about it. There is something which is hidden inside it, and that is what is really a miracle. Before going ahead, let us try understanding the effect of polymorphism or consequences of polymorphism. Important thing is, this polymorphism is a runtime polymorphism. Now, how it is runtime, we will see it shortly. But this is called as a runtime or dynamic polymorphism, whereas method or operation overloading was called as static polymorphism. You will find instance of car or scooter or auto rickshaw are dynamically created at runtime, and that is why it is called as a runtime polymorphism. Whichever instance is created, appropriate start method will be called. Let us try imagining a very fictitious, say, case where there is a garage or there is a workshop. This black door is this is supposed to be a door which is of a garage or the workshop for vehicles. Now, every vehicle is going to try to enter through this gate, and the gate is putting a restriction, only vehicle can enter inside it. So can auto rickshaw enter inside this? Yes, it can enter. Motorcycle can enter because that is vehicle. Car can enter, yes, that is also vehicle. Surprisingly, diagram shows truck cannot enter. Why? Truck is also a vehicle. This door should have allowed the truck to enter through this, because truck is also a vehicle. Again, remember our introductory session or introduction session. Even though in our day-to-day life, even we call truck as a vehicle, we should always go by our model. According to our model, truck is not a vehicle. According to our model, domain model, car is a vehicle, scooter is a vehicle, auto rickshaw is a vehicle, but truck is not mentioned in our model. Remember, we have to restrict to the model at hand, and we cannot apply our common sense here. We have to keep common sense outside the model. We have to get bound with the model which is at hand, and that is where abstraction comes into picture, because many times the abstraction of that noun which is valuable or valid inside the domain model is different than what is existing in the real world. And that's a reason purposely I have shown here truck, and truck cannot enter through this gate because by definition truck is not a vehicle. This is where you will realize or you will find concept of inheritance resonates. Is a relationship with base class, and on the door it is written only vehicles are allowed or vehicles can enter. Similarly, heavy vehicles are not allowed on this bridge. What does that mean? By definition, whatever is a heavy vehicle cannot go on that bridge. Okay. Now, once in the workshop car enters, workshop has written that you only send the vehicles to us, we will repair them, we will test them, for example. So when car passes through this gate, now it's no more a car, but it is basically a vehicle. Remember, this is a bit difficult concept, but this is going to be important for understanding further discussions. Car when passes through this door, now inside the gate, it's only a vehicle. Even motorcycle passes through it, inside a gate it is vehicle. Auto rickshaw passes, it's a vehicle. For example, there is a hall, and inside a hall they are saying that yes, all the volunteers need to enter. Or for example, the social workers, it's a social workers meet, and every social worker is allowed to enter inside. Now suppose minister also enters inside. Yes, the person is a minister, but when the minister enters inside a door, the minister is going to behave exactly like any other social worker. Remember, at that moment, even though person might be minister outside a gate, inside a gate, minister is going to have all the privileges of social worker. Similarly, when these vehicles enter through this gate, the vehicles are going to be appearing as a black box called as a vehicle. Try to imagine it this way rather than this, because this is more of a real world picture. This is what is a software picture of it. It's like a box, and here you will find truck has got a start method, car has got a start method, motorcycle, auto rickshaw, but anyway truck we are going to keep it outside, it's not a vehicle. When car enters inside, it's seen as a vehicle, and remember, vehicle only has got a start method. Now vehicle start method is this implementation. So whenever, now this vehicle is an instance of a car. Even if it is called as a vehicle, it is instance of a car. This is instance of a motorcycle, and this is instance of an auto rickshaw. So inside this gate, this is a very important concept. You should be able to imagine this, that after going inside, and this gate is nothing but a method call. Whenever we are going to call and pass our variables through a method, internally they will be treated as a type which is allowed inside. This is what is a symbolic representation of that concept. Let us try connecting it with the actual code. For example, this is workshop, right? Whatever workshop was there. The functionality was test, and inside this test setup, inside the workshop they are going to test all the vehicles. So their functionality is testing vehicles. So when car enters inside, they will treat it as a vehicle. And in software, how does it reflect? We say class workshop has got some operation called as a boolean return type with test, and only vehicles can be passed through it, and that will be called as a test vehicle. What this method will do is test vehicle.start. Similarly, inside this, the workshop operators, what they will do, whatever vehicle comes in, they will simply start it. If it starts, they will return true. So they will say yes, vehicle is okay, for example. Similarly here, it will call test vehicle.start, and if it starts successfully, it will return true. This is the representation of this imaginary scenario. Now, if you find here that this is a client class, and this class is going to use the functionality of a workshop, And what they do is, first they create something called as a vehicle and pass through it. Will it pass through it? Suppose in this diagram we send some vehicle, will it pass through it? Yes, because vehicles are allowed. So vehicle v1 equal to new vehicle, again treat this as a pseudocode. Okay, let's not attach it to any specific language as such. So whenever vehicle v1 equal to new vehicle, and we call workshop.test, which is nothing but this operation. Now this v1 is an instance of a new vehicle, so this is object created of a new vehicle, whereas it is pointed to by a reference of vehicle type. So there are two things to remember. One is the class of object and class of a reference handler. This v1 is a handler to this object, and these two can be different, as we will see in the later cases. So this v1 is passed to a test operation. Now v1 takes the place of this test vehicle. Inside it, test vehicle dot start means this v1 dot start. And what will happen? It will call start method of a vehicle. And what was start method of a vehicle here? It will print every vehicle starts in different ways. Second case, we create car C1 equal to new car. There is an object of a car and there is a reference of a car which is pointing to this object. And we are saying workshop.test C1. So this time we are passing C1 as an object of type car pointed to by reference of a car. Will it accept it? Yes, it will accept it. In fact, it will not see this, but it will see object of car, and car is a kind of vehicle, so it will allow it. Observe here, car is allowed. Similarly, car instance is allowed to go inside the test method or operation. It will call test vehicle.start, and this start method will be called on C1. C1 is a car, and that is why car's operation will be called. Right. So here appropriately you will observe car's instance will be used for calling the start method. Let us consider a third case. Let us think that vehicle v2 equal to new car. First of all, will this be allowed? An object of type car, can it be pointed to by reference of type vehicle? Yes, because car is a vehicle. So a car standing on the road, can I point to that car and tell my friend this is a vehicle? This is my vehicle. Is that true? It is true, because car is a vehicle. So remember that the vehicle v2 equal to new car, this statement is valid provided it is written in a properly in the implementation language. Right. Now I am again calling the test method and passing this v2. Again, what will be passed on here is object of car, and this start method. Now question comes that the reference is of type vehicle, whereas object is of type car, and now calling start, will it call start method of a vehicle left hand side or a right hand side? Remember, always listen very carefully. Even when we are passing v2 to it, v2 is an object of car, always inside a method, this test vehicle is now representing v2 internally. So when we call start method on this, always method of that object will be called, and it will ignore what reference is pointing to it. So what will be called here when we pass the new car? Exactly like this. It will call the start method of a car itself. So workshop.test v2 will definitely call operation on the car. Now this one is a very strange one. What we are doing is we are trying different permutation combination, that is car's reference is now pointing to an object of vehicle type. Car's reference and object is of vehicle. First of all, is this true? If there is any vehicle standing and I am calling, see, that is my car. A vehicle can be anything, scooter, it can be auto rickshaw or anything. Or if I say vehicle inside this building is my car, that's not true, because every vehicle is not a car. In fact, if you see by definition, every car is a vehicle, but every vehicle need not be a car. A vehicle can be either scooter, auto rickshaw or car. And that is why this description in a red rectangle is not valid at all. So there is no question of calling this operation with C2. This itself is into trouble. So you will find that this combination is not possible, but with all three, always whenever we pass inside an operation, start operation of that proper object will be called. And here you may notice this method does not know the type of object of this reference. If you have seen the implementation of this class, it does not understand whether test vehicle is a car or scooter or truck, but appropriately it is calling dynamically at runtime the operations of appropriate classes. This is what is consequence of something called as a polymorphism. Now I am sure you must have already appreciated that without knowing the type of an object, it's dynamically calling it. Imagine a scenario, I have got an array of vehicles and I am passing one by one to this method. What this method will do is, or rather whatever that compiler or the language platform will do is, every time I call on the next element of array, it will try to find out is it car, scooter or truck, and accordingly it will call start method. That is why it is called as a runtime polymorphism, because the binding is happening at runtime. What is the advantage? You will find another surprising way of understanding it. If at all I add afterwards, after writing all that code, a class called as a truck here, and now you will find truck is also a valid vehicle, so truck also can pass through it. And similarly, if I make an instance of a truck and pass to it, that will also be accepted even though this method body was written before the truck class. This is what is something which is really a great miracle or a great feature which we can use in object-oriented programming. So typically all are equal means all the classes, say car, truck and scooter, are treated equally by this method. But there are certain things that they behave differently. All these classes, they look equal, but when you call a start method, they behave differently based on their concrete dynamic overriding implementations, right? If you have not understood the polymorphism through this, I recommend again go back, watch these slides again, because this is the most important part in object-oriented programming. Please do not skip if you have not understood it. Go back and again watch it. By now, I assume that you have understood the polymorphism as explained earlier. And let's go ahead and find out more detailed understanding or consequences of polymorphism. Now we have seen that there are 4 different implementations of same start method or same start operation in these 4 classes. Like this is a base class and these are derived classes. At this moment, ignore whatever is abstract and whatever is in italics. We just imagine that our previous, okay, let's go back to this diagram. And let us see that the consequences of this. Okay, let's do a thought experiment on it. Imagine there is an artist and artist can draw whatever we tell that artist to draw. If we tell the artist to draw a car, artist will be able to draw it. If we tell the artist to draw scooter or auto rickshaw, again artist will be able to draw it. But if we tell the artist to draw a vehicle, artist will not be able to draw it because there is nothing like a unique vehicle. Car we can see in the real world, scooter we can see, auto rickshaw we can see. It has got very descriptive features But vehicle is just a term used to address all these things together. Exactly same hierarchies consider animal, dog, cat, snake, the cow. You can draw dog, you can draw cat, the artist can draw snake or cow, but artist cannot draw animal. Similar is about a fruit, mango, banana, jackfruit. And you will observe there is generally a no requirement of making an instance of a base class. You will find instance of a base class is never required because you will never see new vehicle because there is nothing called as a vehicle. You may say new car, new scooter, new auto rickshaw. Maybe you will be able to use a reference of a vehicle to address them. You may say this is my new vehicle or these three are my vehicles. One is car, one is scooter, one is auto rickshaw, but this is car, this is scooter. So you will find a specific instances will always be created with something called as the leaf classes. These are not leaf classes, these are base classes to some another class. And this is where funny thing is going to happen. We have seen in this case that whose start method will be called whatever is the instance. So if it is a vehicles instance, then only vehicle start method will get called, and we have seen in practical situation there will never be an occasion to create an instance of a base class called as a vehicle. And you will observe this implementation will never be called. This implementation will never be called because always practically the instance will be of a car, scooter or auto rickshaw. Imagine here what is entering inside is either car, motorcycle or auto rickshaw. You won't see somewhere a vehicle has come and trying to enter in. Once it enters inside, it will be treated as a vehicle. And what we can do with this vehicle? We can call a start operation on it. Observe here, vehicle has got a start operation. But whenever this car is actually this car after entering inside. So when I call start on this start is going to get called. Whenever I call, the operator is going to call start operation on this start will get called. For this start, auto rickshaw start will get called. So you will find vehicle must have a start method, otherwise this operator will not know what needs to be done. And that is where having a start method here is must, but implementation of this start method will never get called because there is no occasion when we call this instance. And this is a very tricky thing, just to have a start method here so that the people who are going to see it as a vehicle will see start method, and not having the implementation. This condition is fulfilled by something called as an abstract method or operation. Whenever we declare this operation as abstract, object-oriented platform allows us to get rid of its implementation. So if we declare our operation as abstract, we do not have to provide any implementation to it. Of course, the language specific things change, because in C++ it's going to be a pure virtual operation, but in Java it is going to be abstract operation. Now imagine we have got abstract operation here and we have got implementations here. To override operation, we need operation in base class, and that is fulfilled by this abstract signature. Now abstract operation just has got a signature, and that fulfills the condition required for overriding it, because if we override, then only we get the advantages of polymorphism. And that is where making an operation abstract helps us. How do we show that in UML? We write that into italics. Now the way it is shown in italics varies dependent on the tool which we are going to use for drawing UML diagrams. But any name of an operation written in italics is treated as abstract operation. Now another rule. Method is abstract, right? Now this abstract method is there, but still suppose we convert this into abstract method, and that is why we do not have to give this implementation. Only there are 3 implementations in the child classes. Problem is, if someone writes new vehicle like this code and passes it on to this method tries to call start. Now you will find if at all a start method is called, and if start method we have made it as an abstract method doesn't have implementation. So this code will get stuck. What to implement? There is nothing to implement. To avoid this situation, remember another rule which I am telling you. Rather, it is from object oriented, it is not because I am telling you. Remember and listen carefully. If even at least one method in a class is abstract, we must make that class itself as abstract. And how do you represent it? This is called as a stereotype. So less than, greater than kind of the symbols, and we write abstract into it. Whenever we write a class as abstract or declare class as abstract class, consequence is that we cannot make any instance of this class. So now we can collect the pieces together. We have seen car, scooter and auto rickshaw are practically the classes whose instances will exist. Vehicle is a base class just to represent them collectively, and vehicle class does not require implementation of start method because there is no occasion when it will be called. As this operation is abstract, the instance of vehicle cannot be created, and to force that onto the clients, we have made this class itself as abstract. So once we have made the class as abstract, we will never be able to make instance of this. And when we cannot make instance of this, there is no question of calling the start method on instance of this. So now vehicle is an abstract class, but vehicle is being used as a placeholder here, you will observe. It's a base class. So we are treating every vehicle inside the workshop as a vehicle. Inside the hall, whether it is a minister or not, we are going to treat them like a social workers. So if minister says, I want my protection, sorry, right now you are not minister, you are social worker. So that kind of a box, try to imagine, it will definitely resolve your queries regarding polymorphism. But we must have here start method, otherwise we will not be able to call it on car, motorcycle or scooter, because vehicle must have a start method. So remember, not having the start method here does not allow us to override it, and that is why polymorphism will not happen. Having a start method, either abstract or non-abstract, will help. In case we do not override in a child class, that is also fine. In that case, the operation in a base class is also available to child class by inheritance, and that will get executed. So when every child class has not overridden an implementation, in that case we may keep this as non-abstract. Now operation is kept non-abstract because, for example, scooter doesn't want to override it, or there are classes which do not want to override it, they want to use it as a free implementation. Now you will observe in vehicle class all methods are non-abstract. We have seen the rule that even at least one method is abstract, we must make class as abstract, otherwise it won't be allowed. But what is converse true? If there are all methods which are non-abstract, non-abstract means concrete methods, those are called as concrete methods, like this where there is an implementation. Can I declare class as abstract when there is not even a single method which is abstract? Yes, it is allowed. It is allowed to make a class abstract even though every method in that class is a concrete method, or every method in that class is a non-abstract method. Then why do we make this class as abstract when there is not even a single method abstract? This is just to stop the clients from making instance of this. And in general, we are not going to go into depth and the reasoning. It is always a recommended best practice that if it is a base class to any other classes, always make it abstract. We are not going into depth of reasoning of this, but as an industry standard code, every base class, if it is base class to other classes, we must make it abstract always. Even if we do not make it, sometimes the code might run, but as a best practice to make a robust code, we always should make every base class as abstract, irrespective of whether that class is going to have abstract methods or not. So remember, abstract method is represented by italics, making it italics, and abstract class is represented by something called as a stereotype, which is written like this as abstract. Now again, let us refer back to this diagram. You will find such abstract class can be used as a placeholder and to restrict the clients from calling very specific methods. Now you will find car, when it goes inside, it is treated as a vehicle and only start method can be called, even though you might find that car may have like this. Car may have its proprietary methods. See, these are proprietary methods. These are not overridden methods, right? So what we can do is, when it is taken as a vehicle reference, we can call only methods which are there in vehicle. Let us go back to code here and check. So even if this car is going to have play music operation, if it's proprietary operation, inside this method we can call only start. So how it happens? Listen carefully. Now inside this method there is a parameter on which we are calling start. First of all, the platform will check. We are calling start method on test vehicle. Okay, what is test vehicle? Test vehicle is a reference of type vehicle. Okay, let us check whether vehicle class has got a start method. Yes, it has. Whether abstract or not, that is fine. It has got a start method, so this statement is allowed, because first of all, vehicle has got existence of a start operation. Okay, now which exactly start method should be called? Because you will observe that inside suppose it is a car's instance, there is a start method here as well as here. Now when it is coming to actually calling an implementation and executing it, a start method of concrete class is called and not of this type. So two things: if it is a vehicle reference must have a start operation, and child class, if it has implemented different overridden method with the same name, that will get called. So it will check vehicle has got a start method or not. Yes, vehicle has got a start method, and object is of car, so car, this implementation. If object is of scooter, call this. This is called as a polymorphic behavior. I know it's bit difficult to appreciate, but I would suggest please go through it again and again and try to master this technique. This is where you find usage of an abstract base class, because inside this wall we are treating all of them equal. Like our example of a social worker, whether you are a minister, whether you are a principal, whether you are a dean or owner, businessman, once you cross this door, you are social worker, and your privileges of being minister or professor or anything are blocked inside this wall, and whatever functionality of a social worker is there is applicable. And that is what is basically usage of abstract class or base class and polymorphic behavior. Let us get to the next concept called as an interface. This is going to be only at an introductory level, because interface is the most difficult concept in object-oriented platform. Interface is mostly used at a design stage and generally not used at a domain model analysis. Interface is something similar to abstract class. What is abstract class? Abstract class means its instance is never created, its reference is only used but never created as an instance, and the operations inside abstract class can be abstract, meaning there is possibility that for some of the methods or all of the methods implementation may not exist. Now interface is a concept so that we can bind some of the operations or a contract onto classes. For example, bird is living thing, aircraft is vehicle, is a kind of relationship, right? Remember, this is inheritance symbol or generalization specialization. In upper direction it is generalization, in lower direction it is specialization. So living things have got a food type and living things can eat. Bird is going to eat because bird is a living thing. Similarly, aircraft can check fuel because every vehicle has got a fuel volume and can check the fuel. So aircraft is a vehicle. At the same time, we find bird as well as aircraft, they do have the ability to fly. Now how to fly is completely different thing. Aircraft flies with artificial mechanisms, whereas bird flies with their own wings. But flying is something which is operation, which is a contract with any flying object and outside world. Outside world can always accept it. If it is a flying object, it will fly. So similarly, this interface, observe here how interface is marked like a abstract class with a stereotype. Flying object as an interface is binding operation called as a fly for both these classes. This relationship is called as realization, meaning there is no really implementation present here, but bird is going to make it real by providing an implementation. This must have suggested you that why we are saying there is no implementation, because if we are calling this as an interface, interfaces will never have implementations of operations. Two things for interfaces: no attributes and no implementations for operations. They are just operation signatures, so that those are bound on the classes which are going to realize them. All methods are going to be abstract, no implementations and no attributes. Of course, you will see in specific languages there can be constants described, but those are really not treated as an attributes, they are constants. Now interface is used for binding a contract with the classes, like this fly is a contract. So any outside client is going to access these two objects as flying object, like our gate door, right? Suppose it is written here only flying objects. Obviously you will find that living things can, all living things may not pass through, all vehicles may not pass through, but bird will pass through and aircraft will pass through. Living thing as a dog will not pass through because it is not implementing flying object. This is equivalent to multiple inheritance, but this is not multiple inheritance because bird is not going to inherit the concrete methods or the implemented methods. Remember, interface is more of a concept and not as a keyword. In some of the languages it is available as a keyword, but in some languages it is not available as a keyword. So for example, in C++, if you write a class, or in Java also, if you write a class with all methods abstract inside it and not even a single attribute, it can be treated as an interface. So remember, abstract classes can work as interfaces, but interfaces cannot work as abstract classes because the classes cannot inherit. For example, class inherits another class, class realizes interface, and the third relationship which is not shown here is interface can inherit from another interface. So remember, this is going to be only at an introductory stage for interface. We are not going to cover interfaces in depth. So if we want to just summarize whatever we have studied together, we have seen the inheritance, code reuse made from that. So whatever is common we segregate, whatever is varying we separate out. This is about the inheritance. We saw operation overloading. Operation overloading means same method name but different signatures. Operation overloading can be done in the same class or class and its child class also. Operation overriding cannot be done in the same class because in operation overriding method name and method signatures must match. Operation overriding can be done in a base class and its child class, where we are saying that child class overrides operation which is given in the base class. When the child classes start overriding the operations given in base class, we can use them as a polymorphic way. Meaning polymorphism means that dynamically we can assign any object at runtime against the reference of a base class, and whenever we are going to call an operation present in a base class on the child class instance, operation which is there in the child class or implementations available in child class is going to get executed. So remember, operation overriding means same operation multiple implementations, or same method different interpretations. That is also sometimes people describe it that way. We have seen abstract method means no implementation is given. Abstract class means its instance cannot be created. If at all there is at least one operation which is abstract in a class, we must declare that class as abstract. But even if all the methods are non-abstract in a class, still we can declare that class as abstract. So we can declare any class as abstract irrespective of whether it has got abstract methods or not. And what happens if we declare class as abstract? We cannot instantiate it, or we cannot create instance of it. So obviously it is used to discourage clients from making instance of some class, and we mark it as abstract. Now once we come to interface at the end, interfaces are used to bind the contracts with the classes. This statement is a bit difficult, but right now we will not go into depth because it is more useful, this concept, at a design and implementation stage, not at the domain model level. Interfaces will never have any attributes and it will never have any non-abstract methods. All methods will be abstract methods. Interfaces are declared with the help of the stereotype, and this is where different concepts related to OOPS are complete.